In this podcast, we're going to talk about metallic bonding, which is the kind of bonding that holds metals together when they are all by themselves. So metallic bonding occurs when metals are bonded together, and we call this a sea of electrons, or an electron sea. What happens is, remember that metals always want to get rid of their valence electrons. So here are metals, all lined up together. They all have valence electrons, and they are trying to get rid of them. And then what happens is those electrons just swim around among the cations, and we call this an electron sea. The electrons are moving around like crazy. This is why metals conduct electricity so well. And alloy is when you have two different metals that are bonded together. The bonding is pretty much exactly the same, but now you've got the cations here that are yellow, and you have other cations that are gray, but they both have electrons that they're getting rid of, valence electrons. And so those electrons combine in the electron sea, but we have two different types of cations, and alloys can get a little bit complicated, but that's the basic idea. So an example of an alloy would be brass. And brass has more than one metal bonded together. Properties of metals: they're shiny, they're malleable and ductile. This is, and they conduct electricity very well. So we can help explain the properties of metals. Their melting points generally are quite high. Most are above 500 degrees. And something a little bit weird happens. There's a huge melting point difference between group 1A, so the alkali metals on the periodic table, and group 2A, the alkaline earth metals. Even though they have almost the same, similar number of protons, if we look at lithium versus beryllium, they're in the same period. They're not very different in size. Lithium has a melting point of around 200, a little less than 200, and beryllium is all the way up here past 1200. We see the similar thing: sodium versus magnesium, potassium versus calcium. So these are elements that are right next to each other in the periodic table, yet the melting point is a huge, huge increase. And this happens because the electron sea that happens in the metallic bonding, it has twice as many valence electrons. So group 1 here, 1 valence electron. The blue guys, group 2, has 2 valence electrons. So we've doubled the number of electrons, doubled the strength of the bonding. So the attraction is much stronger. And whenever you have stronger attraction, the melting point is going to be higher. Mechanical properties. This is very, very different than the ionic compounds that we saw in the ionic model. If you've got metallic bonding and you hit it with a hammer, apply an external force, the electrons cushion all the cations so that they don't bump into each other, they don't repel. So what happens is the metal will deform here. They slide past each other, they don't repel, and this is why metals are so malleable.